What is the derivative of sine of x? That's cosine x. But wait, what happens if this is not x? If this is 2x squared plus 5, or 3x minus 7. So it's not just x. The derivative of sine of u is cosine u times u supreme. What does that mean? If I said to you, can you tell me what the... Mine? Yeah. We'll put on silent. Quiet there. Text message, why do all math teachers wear glasses?
Nobody beats the clock.
It says, it helps with division. It helps with division. They're like, you gotta be kidding. They goes, haha, it's a student sent me that one. Wait till I see it, I'm gonna kill her on Monday. One of my physics students. Let's see, we have sine x squared, not just x squared. So the derivative of that is going to be what? Cosine x squared, but that's not enough. Oh. Cosine, that's cosine squared. Cosine x squared times the derivative of x squared, which is what? 2x. And usually we like to write the 2x first. What's the derivative of sine x to the fifth plus 7x squared minus 4? So notice no longer x, we're dealing with the bigger expression now. This becomes what? Cosine x to the fifth plus 7x squared minus the 4. Are we done? No, times the derivative. What's on the inside? What's the derivative of this? 5x to the fourth plus 14x. So you don't multiply this time. That's why I like to put them on the front, because people say, why don't you multiply these guys together and make it one thing? You can't. This is not separate from the cosine. This is one thing, and you can't multiply this by this. So you can only take this value to the front. Times the cosine of x to the fifth plus 7x squared minus the 4. Let's look at the derivative cosine. So this is one of them now. We're making them bigger. It's no longer just sine of x. What is the derivative of cosine u? Want to take a guess? Negative sine of u times what? U supreme. I should put the whole thing here. So let's look at that. Can you tell me what the derivative of cosine e to the x? Negative sine e to the x times the derivative of this. What's the derivative of e to the x? E to the x. Clean it. That'll be negative e to the x times sine e to the x. What is the derivative of cosine x cubed minus 8x. That'll be negative sine x cubed minus 8x times the derivative of this, which is what? 3x to the second minus the 8. So when you clean it, I like this first. 3x to the second minus 8, and I'll take the minus in the front with a 2. See the minus I put in the front? Times the sine of x to the third minus 8x. And we can use the same logic for the rest of them. So I'll go through them one by one. There are 4 of them. And I'll do 4 more, I'll put them up there, then we'll do some examples on them. What is the derivative? I'll make it in red here. Of tangent u isn't that secant squared u? But now you're going to multiply it by what? U sub prime. You got to add that little extra piece. What's the derivative? I'll do an example in a minute there. Secant u. Derivative of secant is secant tangent. And add that little extra piece, which is what? U sub prime. What is the derivative of cotangent u? Negative, right? Negative cosecant squared u times u sub prime. And finally, what's the derivative of, instead of secant, we'll do cosecant u. Negative cosecant u cotangent u times u sub prime. Let me put the sine cosine. Maybe you'll notice something to help you memorize positive and negative. We said sine of u is what? Cosine u times u sub prime. The derivative of the cosine of u is what? Negative sine of u times u sub prime. I don't know if you notice, we have 6 trig functions. 3 of them begins with the letter C. All the ones begin with the letter C. You see it? What's the sign here? Negative. So if you're not sure if it's positive or negative, just say, does it begin with the letter C? Yep, it's a negative value. The rest of them are positive. That's where some people actually mix the sign a lot of times. Is it positive or negative? They're not sure. So if it starts with the letter C, the function, the derivative is going to be a negative value. Okay, let's take a few examples on that. And maybe I'll add one more. And then what about e to the u? We did e to the x. So we have some space to squeeze one more here. What is the derivative of e to the u? What do you think? E to the u times what? U sub prime. So let's take a few examples on that and go through them. Y equals e to the 5x. Can you tell me what the derivative of that? Now remember, this is really u. This is e to the u. So u here is what? 5x. So the derivative of that should be e to the u times u sub prime. And we said u here is equal to 5x. So if you plug it in, that's what? E to the 5x times the derivative of 5x, which is what? 5. So the answer will be 5 e to the 5x. Y equals e to the x squared minus 7x plus 6. What is the derivative of that? What do we have?
2x minus 7.
Okay, you already moving with the front? Okay, so it's e to the x squared minus 7x plus 6 times the derivative of this, which is what? 2x minus 7. Nico already put that number in the front, or that value in the front. Is not a number. And that'll be my answer. Y equals e to the cosecant x. Might as well have fun. This is u now. Use cosecant x. What's the derivative of that? E to the what? The cosecant x times the derivative of cosecant. What's the derivative of cosecant? Negative cosecant x cotangent x. And if you want to write this one first in front of this, that's fine. You want to leave it at the end, that's fine. Let's see if you remember the extended power rule. In case you forgot, we said if you have y equals x squared plus 7x to the power of 200. And what is the derivative of that? Remember we said last time? Or the general power rule. We say you move the power to the front, and what do? Write that to what power now? 200 minus 1, which is 199, times the derivative of this. Use a prime, basically. What's the derivative of x squared plus 7x? 2x plus 7. And if you want to multiply the 200 times that, then multiply it by this, go ahead, knock yourself out. Okay, can you tell me what the derivative sine cube 5x? It's not sine 5x cube, sine 5x cube. Well, what does that mean when you look at it? Or sine 5x to what power? 3, right? I can use that rule there. The power is different than 1. What's the derivative? Move the power to the front. Times sine 5x to what power? 2 times the derivative what's on the inside. What's the derivative sine 5x? And be careful there. Cosine 5x Keep going, you're not done. Times the derivative of this, which is what? 5. The derivative sine of 5x is cosine 5x times the derivative of this piece, which is the 5. So now if you want to clean it a little bit, you can go 5 times 3, which is what? 15. I'll put the cosine in the front, no reason. And I'll make that sine squared 5x. Let's add a couple more properties here to the list. What is the derivative with respect to x of the natural log of x? If we go through the math and derive that using the 4-step process, you will end up with what? 1 over x. I can derive that just going through step number 1, f of x plus delta x. Step number 2, f of x plus delta x minus f of x. Step number 3, divided by delta x. Step number 4, take the limit as delta x approaches 0. If we did that, you'll end up with that answer. I'm not going to derive it. What about if that's a u, not an x? If that was a u instead of x, still going to be 1 over u, just like 1 over x, except now times what? The derivative u, which is what? U sub prime. So a lot of times you see that written as u sub prime over u. If you want me to prove, actually, I thought even a different way to prove this one. That the derivative of the natural log of x is 1 over x. I was sitting there and thinking about it, and I go, you know what? I can prove that quickly for you, because I know you're excited about the proof there.
Just back it up real quick. Why do we do cosine 5x times 5 as well?
Because the derivative of sine of 5x is what? What's the derivative of sine of 5x? Cosine 5x times the derivative what's on the inside of 5. I want to prove to you that the derivative of y is, derivative natural log of x is 1 over x. So let me take y equals the natural log of x, and let me try to find what y sub prime is. There's an easier way to prove it instead of doing the 4-step process. What about if I raise both sides, I go e to the power? I'll end up with what? E to the power of y equals, what is e to the natural log of x? Just x. I might even have that on the board. Do I have it here? Tech Math 2, we did that solving equations. That's how we used to solve them. Now take the derivative of both sides with respect to x. If you take the derivative of both sides, this is the derivative e to the u, it's e to the u, except we're using y here. It's e to the y times what? Y sub prime. And what's the derivative of x? Isn't that a 1? Okay. What is y sub prime equal to? 1 over e to the y. And if you look inside this box, what is e to the y equal to? X. That's a quicker way to prove it than instead of the 4 steps. So the derivative of the natural log of x is really 1 over x. And there's the proof right there, without having to do the 4 steps. Quicker way to prove it. Okay, let's try a couple of these problems. What's the derivative of the natural log of 2x? Isn't that 1 over 2x, so that's what u is 2x, times the derivative of 2x. What's the derivative of 2x? 2. So when you simplify it, that's 2 over what? 2x. Can you simplify that more? 1x, or 1 over x. What's the derivative of the natural log of x squared minus 5? One over what? X squared minus 5 times the derivative of x squared minus 5. What's the derivative of x squared minus 5? 2x. So that's 2x over x squared minus 5. What's the derivative? Let's have fun here. X times the natural log of x. Oh, wait a minute. We have multiplications. See that? X times the natural log of x. So what method? Product rule. F of x equals what? X. G sub x equals what? Natural log of x. What's the derivative of f? 1. What's the derivative of g? 1 over x. So the answer to this is going to be f times g sub prime plus g times f prime. F is x, g sub prime is 1 over x. Add to it the natural log of x times the 1. That's 1 plus the natural log of x. Let's try another one. Another idea struck me. What's the derivative of the natural log of the square root of x minus 5? I don't know. Somehow x minus 5 stuck in my head today. When you look at that, this is u, right? This is really u. So if you want it, you can go 1 over the square root of x minus 5 times the derivative of the square root of x minus 5. It's 1 over u times u sub prime, the derivative. And now I'm just going to take the derivative of that. Once I take the derivative of this, I'm in good shape. What is the derivative of this? What method am I going to use? The extended power rule, yep. So that's 1 over the square root of x minus 5 times, when you look at that, that's the derivative of x minus 5 to what power? 1/2. So notice the power is different than 1. Let's take the derivative of that. We move the power to the front. And what do? Subtract 1 from the power. When you subtract 1 from the power, it becomes what? Negative 1/2 times the derivative, what's on the inside of that? 1. When I clean this, isn't that 1 over 2 times the square root of x minus 5? Because that's a negative 1/2. And what is the square root of x minus 5 times the square root of x minus 5? X minus 5. Couple more rules here, then we're done with this section. This one I left out last time. Maybe we'll take a short break after that and answer questions and come back to the last section. We have one more section to cover tonight. What's the derivative? Let me refresh your memory here. What's the derivative of e to the x? E to the x, good. What's the derivative of e to the u? E to the u times what? U is a prime, or the derivative. What about if it's not e? If it was some number beside e? What's the derivative of a to the x? Any number beside e, like 2 to the x. The answer to that, just like e to the x, this will be, I'm leaving a space there, will be a to the x, just like e to the x, except a little adjustment, the natural log of a. You got to multiply it by the natural log of a. So if I ask you, what is the derivative of 2 to the x? It is the natural log of 2 times 2 to the x. What is the derivative of 5 to the x? It's the natural log of 5 times what? 5 to the x. What's the derivative of pi to the x? It's the natural log of pi times what? Pi to the x. So we make a little adjustment to it when that number is not e. We multiply it by the natural log of that number. And again, what about if it's not x? If it was more than x, like a u, just like this. What's the derivative of a to the u? Again, it will be similar to this one with the adjustment, which is what? The natural log of a times a to the u times u sub prime. Just like this one, except we add the extra natural log of a to it. So here we go. What's the derivative of 7 to the power of x squared minus 4? First, it's the natural log of 7, that'll be in the front, times what? 7 to the power of x squared minus 4. Am I done? No. Times the derivative of x squared minus 4, which is what? 2x. It's not often we do a to the x, to be honest with you. But you'll see them in math. But in real life, when I teach engineering, I don't deal with 5 to the x, 7 to the x. I deal with e. E is very popular for us, But you never know. What's the derivative of 3 to the power of x cubed minus 7x squared? That would be the natural log of 3. That's the first part. Times 3 to the power of what? X cubed minus 7x squared. There's one more piece left, and that's what?
Times 3x squared.
Yep, minus what?
Minus 14x.
Minus 14x, which is the derivative of this. These two are actually popular, e to the x and e to the u. But a to the x and a to the u, it's not really like, if I have to give a percentage how often you see them, I will say these probably less than 1% of the time. And the other one is the natural log. We did the natural log of x. We said the derivative of the natural log of x is what? Isn't that 1 over x? And the derivative of the natural log of u is what? 1 over u times u sub prime, or you can write that u sub prime over u. Again, the natural log, for those people who forgot their trig, the natural log means what? Log base what? E. What about if the base is not e? What about if the base is 5 or 7 or 9 or 50 or 10, the common log? So what's the derivative now of log base? I don't know, should we use b for base? Any base. Since I use a in the other ones, maybe I'll use the base a here, so we'll stick with the same notation. I use a in the previous one, so. If it was the natural log, that would be what? 1 over x, right? If that was the natural log of x. But the a here, we need to make an adjustment to it. That becomes the natural log of a in the bottom. And if that was a u, we know this is u sub prime over u, but we have to do an adjustment to that. That's times the natural log of a. Let's do a few examples with that. What's the derivative? Log base 5 of x. It's 1 over x if it was the natural log, but we have log base 5. That becomes ln of 5. What's the derivative? Log base 7 of x. 1 over ln of 7 times x. The natural log is 1 over x. If it's more than x, log base, I'm not going to put the base, log x squared, no base. What does that mean if there's no base? That's the common log, which is log base what? 10. So that would be what? 1 over natural log of 10 times what? X squared. And now you've got to take this, multiply it by the derivative of x squared, which is what? 2x. So when you clean it, that's 2x over the natural log of 10 times x squared. One more example. then we'll answer questions. Log base 9 x squared minus 3. I know I'm going to need the natural log of 9 in the bottom. Might as well just put it there. This is my u, x squared minus 3. And what's the derivative of x squared minus 3? 2x. I can put on the top. So you end up with what? 2x over the natural log of 9 times x squared minus the 3. I didn't simplify this, by the way. Notice I could have canceled this x with one of these x's. I just looked up right now. I was just busy with that. So this one could be simplified to what? 2 over natural log of 10 times what? X. So you're going to simplify your answer. They probably mark it wrong on the test, on the software, you know. Because they always look to simplify their answer.